Right, so I usually start with the question, who uses open source in their work projects or pet projects? And all the hands go up, so just a check question, is there anyone who doesn't use open source? Okay, good, then we're all on the same page. Open source is great because it offers us functionality that we need, like application frameworks or testing frameworks, without us having to write it ourselves. So that's great, right? But then there are also downsides. For every dependency that we pull in, they might bring in a bunch of transitive dependencies, and you end up with lots and lots of dependencies in your applications. And as we've seen, any of those dependencies can have vulnerabilities. So who remembers December of 21? From the uncomfortable giggling, we were all doing the same thing at the time. So log4shell happened. Thank you for appreciating my memes up front here, thank you. So log4shell happened. Funny story, I'm now at JetBrains, but previously I was at bol.com in the Netherlands, an online retail platform. And one of my colleagues there is a log4j maintainer. And he had literally planned to go on holiday when log4shell was disclosed. So instead of going on holiday, he was working 22-hour days for free to help fix this problem. And the rest of us, we got to update all of our applications with the new version of log4j. Now at bol.com they have a microservices landscape where each team is responsible for 5 to 10 different microservices maybe. So it means lots of projects that you have to update and deploy with the new version. So, and then we got to do it again because as you might remember, after the first CVE was fixed, several others were disclosed and also fixed. Thank you so much for giggling up front again. So, you know, then we got to update everything again, which was slightly faster because we just practiced. And then in March of the next year, same coworker, by the way, tried to go on holiday again. Spring4Shell happened. So we got to do all of that again, which was, again, slightly faster because we just had recent practice in redeploying everything. So as we've seen, using external dependencies has pros and cons. As pretty much everything in software development, there's a reason the standard answer is it depends. Of course, the interesting part is always what does it depend on? So I've seen teams that use different ways of dealing with this. On the one hand, there are teams that try to limit the number of dependencies that they use. So they won't use mocking frameworks, but write the mocks themselves. They won't use testing frameworks, maybe application frameworks. They'll write everything themselves. Of course, you won't have known dependencies, but depending on how well you write your code, you might have dependent or known vulnerabilities. You might have vulnerabilities nonetheless. On the other hand, there are teams who aren't critical at all about what dependencies they pull in. We have a problem. There's a library that can solve it for us. Let's just use that. And then you end up with lots and lots of dependencies, lots of transitive dependencies. If you're really lucky, conflicts between those transitive dependencies, and you have to keep everything up to date. Obviously, there's some middle ground here, so please think carefully about the dependencies that you want to use. And let's look at some of the things to consider. The first thing, of course, is does this dependency solve the problem that we have? Is it a good fit? But also, is the size of this dependency relative to the size of the problem that we're trying to fix? We don't want to pull in half the internet just to fix a tiny problem. Maybe there's a better solution for that. We want to consider how well maintained a particular dependency is. Are there a lot of maintainers, a lot of active maintainers? What is the frequency of releases? How fast do they respond to bug reports, or better yet, security vulnerabilities? because there's an XKCD for everything, you might be familiar with this one. A lot of the stuff that we use depends on small projects that are run by sometimes one person, and if something happens to them, the project might go unmaintained. This is sometimes called the bus factor, or how many people can get hit by a bus before a certain library goes unmaintained. I really, really don't like this term because I don't want to think about people getting hit by a bus. So I've heard the alternative term, lottery factor. How many people can win the lottery and never have to code again if they don't want to before this project goes unmaintained? I unfortunately don't remember who coined this term. Another thing we want to consider, or we may want to consider, is the community around particular frameworks or dependencies. Are there a lot of users? Is it very popular? Because if it is, then there are more people who can maybe help you if you have any questions. More people might be writing or talking about it. But also, is the community helpful and welcoming? If you're new to a particular project and you're using it and you have maybe some newbie questions, are they nice about it, or are they like RTFM and figure it out yourself? If you have a PR or you report a bug, how do they respond to that? Are they still friendly and thanks for the bug report, or thanks for the PR, and helping you with that as well? Of course, we all have personal preferences, so also consider, do I even like using this or that library? And is it easy for me to use? Does it do the things that I want it to do? Is the documentation any good? Is there any documentation? There's a thing I like to call Schrodinger's documentation. If there is documentation, people don't read it. But if there isn't documentation, then people will complain that it's not there. So that's always fun. When you select a dependency, what is the impact of adding that dependency to your project? If you're adding something like string utils, that's fairly small and fairly contained. If you ever want to remove it, it will be in several places, but it will be easy to remove. If you use something like Lombok or Reactor, that's going to spread throughout your code base, much like the dandelion throughout a garden. Ask me how I know. And it will be very hard to get rid of it in the future. And of course, if you do decide that you want to use a particular dependency, make sure that you're using a stable and stable version that doesn't have any known vulnerabilities. For example, Jamie Coleman, who will be here later in the week, from Sonatype, told me that there are still people downloading the vulnerable version of Log4j, even though it's been fixed. And I took this screenshot yesterday. It's at 33% still of vulnerable versions. So, do you want to get that picture? Since we have such a small crowd. Okay. You're welcome. So where can we find this information? Of course, we can go to Maven Central. We can find a particular version that we want to use. And they provide information on the OSS index on whether, so the latest version. I'm using Jackson Databind as an example because they, being a serialization, deserialization library, which is a fun topic for security, often have known vulnerabilities that they then fix. So the latest version doesn't have any known vulnerabilities, but if you go back to a slightly older version, then there are known vulnerabilities. So you can find this information on Maven Central. JetBrains have a website called Package Search, where you can also find this information. So you can find the information about a particular library you might want to use, with links to Stack Overflow tags that might help you with questions about this library, what license it uses, link to GitHub and the documentation, as well as an overview of different versions, just like Maven Central has, so you can see what the frequency of releases is, etc. And as I'll show you later, if the internet collaborates, you can also get this information right inside IntelliJ IDEA. Finally, you can of course go to GitHub or wherever the code is hosted to look at the actual source code, as well as additional information about the project. So the frequency of releases, but also the activity on the project. You can go to the Insights tab to see basically the type of activity on a particular project, pull requests, etc. And you can go to contributors if you want to see how many active contributors there are, when they contribute. So I learned that Jackson, for example, is pretty much maintained by one person who occasionally has people who contribute. So an entirely different rant. If we can get more people to work on open source, that would be great. But overall, we probably will have, well, everybody here uses open source, so we all have dependencies that we all need to maintain, which maybe isn't our favorite thing because, you know, writing new code for new features is more exciting. So let's look at some of the ways that we can keep them up to date. So one of the ways, so first of all, you need to know what dependencies you have. Just for a quick show of hands, who uses Maven? Okay, most everyone. Who uses Gradle? Some people, okay. I'm more familiar with Maven, but I'll show you how to do it with both Maven and Gradle. So if you're using Maven, you can ask for the dependency tree, which will tell you your declared dependency and their transitive dependencies and you can go in the command line and follow the lines all the way down. You can do some filtering on that as well, of course. But you can also ask Maven for dependency updates. So it can tell you, hey, there are new versions available that you can update. And this is what I used to do years ago to know whether there were dependencies that I could update on the project I was working on. Of course, so by now 2.15.2 is out, but when I took this screenshot, that was actually a release candidate, which you can't tell in the Maven output. Finally, there's a command that will let you analyze dependencies, so it can show you whether you have, for example, unused dependencies that you have declared. By the way, this project that I'm using here is an old project from my GitHub graveyard of, you know, stuff that you do and never update. So this is not running in production anywhere, don't worry. I'm not doing anything with this. It's just a perfect example of an extremely outdated project, which came in handy for this talk. So that's why I'm using it. And of course, if you have JUnit declared but not used, maybe add some tests to your project. Bad past me. So in Gradle, you can also ask for dependencies, which will show you the dependency tree. Sorry, can't English. If you want to ask Gradle for dependency updates, you need to use a separate plugin, for example, the benmains version. And then you can ask it, what are the dependencies that I can upgrade? And you can also analyze dependencies, for example, using the Nebula plugin for the unused dependency rules, if you want to see if there are any dependencies that you've declared but are not using, so that maybe you can remove them. So in IntelliJ IDEA, let's go there if the internet collaborates. So who apart from me opens a project and then goes to the POM XML or build Gradle to see, I wonder what dependencies they use? Not just me, okay. So one of the ways to see what dependencies are used in a project is you go to the POM XML or the build Gradle to see what dependencies there are. If you're using IntelliJ IDEA, you can also go to the project tool window and look at all of the jars that are downloaded for those dependencies. Or of course, in a Gradle project as well, you can see the dependencies. You can also go to the Maven or Gradle tool window where you can see the dependencies. And here you can expand or collapse as needed. So it's easier to see the dependency tree in this way, because you can focus on what you're looking for. Also works with Gradle. And you can analyze dependencies. So you can see which dependencies you're using and where you're getting them from. And you can search for specific dependencies here. You can select scopes. So depending on whether you're using Maven or Gradle, it will have the Maven or Gradle scopes. And you can see which dependencies have conflicts, for example here. And then in the Maven tool window, you can see whether they've been resolved or not. So you can see that some are omitted for conflict. You can also do this in Gradle. Wait, wrong window. There it is. Which apparently doesn't think it has resolved dependencies. Always something goes wrong in the demo, sorry. So another way to manage dependencies is, of course, you might want to add dependencies. You can use code completion in your build Gradle or POM XML. Did everybody know that you can do that, or who didn't know that you could do that? You learned something new, yay! So you can use code completion in your POM XML or build file, build Gradle, sorry. And as you can see with the little squiggly, IntelliJ is trying to tell us that something is wrong here. It will show you that there are known vulnerabilities in these dependencies. And if you hover, like I'm now hovering over this dependency, and it will show you which CVEs are known vulnerabilities in this dependency. And we can update it either by clicking this link, or you might be familiar with, nope, that is not what I wanted. Alt-Enter will also give you the option to update the version. Alternatively, we can go to the dependencies window, where we can also search for dependencies if the internet allows. You do need internet connectivity for these features, so praying to the conference network that it will let me. So here you can also add dependencies. And as you might have seen, we can upgrade dependencies here. So we can either upgrade to a specific version, or upgrade to the latest version, or we can even upgrade all dependencies in one go. Yes? Yes? So you're saying if I'm using Spring, the transitive dependencies will get their version from Spring? Okay. I'm not sure. But if you want to, we can look into that, if you don't mind coming back afterwards. So, and also you can remove dependencies from here. And as you can see, it shows you the information of the dependencies inside your IDE. And finally, I can't type if people are watching. You can check for vulnerable dependencies right inside your IDE. So as you can see here, it's showing me all of the known vulnerabilities inside my project with a severity, so either high or medium. And like I said, this is a very old project, so everything's outdated. And you can see here all of the known vulnerabilities, and we can see the information of the CVEs right inside our IDE. And all of these can help you keep your stuff up to date as you're working on the project, which is what I wanted to show you. And then we can skip a bunch of slides that I had just in case it wouldn't work. And also shameless self-promotion. I create videos for the IntelliJ IDEA YouTube channel, so I have a series of videos on managing dependencies inside of your IDE if you want to have a look at that. I will, at the very end of the slideshow, provide you with a link and QR code to a page on my website that has all of the links, including to the slides, etc. So for the tools that we've seen so far, there are pros and cons. The pros are that you can check dependencies while you're working on a project. And also if you're importing a dependency with known vulnerabilities, IntelliJ IDEA will tell you with the little squiggly lines. That's the official name for that, squiggly lines. But the downside is you have to check out each individual project. So if you're working in a microservices landscape, that means you have to go check out every project and see if there are updates available. And then, of course, you have to apply those updates and verify that everything still works. But everybody has a really good test suite to do that, right? Different rant. So another set of tools that can help you with this is our software composition analysis tools. There are a lot of different tools that you can use for this, but as developers we don't always have, or often don't have, any say in which ones we use, so I'm not going to go into the details of all of the different tools, but hopefully the organization that you work for has something that they're using. These tools can scan all of your repositories, and if not, talk to your security department. I'm sorry about the anyway, maybe talk to someone who can fix that for you. So hopefully you'll have something that can scan all of your repositories and your containers for known vulnerabilities. At my previous job we used Aquasec and then an internal tool to show that filtered by team, so it could show for your team, these are the applications you're responsible for, you have these known vulnerabilities with these severities, and then you can go to one place where you can see, okay, we need to update stuff or not. So the upside is I no longer have to check out each of my individual repositories. The downside is I do have to go to the dashboard to see if there is stuff that I can update, and then again I have to apply and verify those updates. So the next set of tools that we can use are bots. And for Java there are three options: Dependabot, Renovate, and Sneak Open Source. And I've looked at all of them. So let's do a quick overview, excuse me. So Dependabot is GitHub native, and it has three features. It can alert on known vulnerabilities. It can do security updates, so updating versions if there are known vulnerabilities. And it can do version updates if there are new versions of a library, but not for security reasons. Because it's GitHub native, it's really easy to turn it on if you're using GitHub. I've read that you can also use it on GitLab if that's what you're using. I'm not sure about any other CI/CD platforms. So on GitHub you can enable it via the settings. If you enable Dependabot alerts, it will show you on your projects a yellow bar saying we found vulnerable dependencies. You can click the button to see the alerts on what's vulnerable and you should update and their severity. It will create PRs. If you enable the security updates, it will create PRs for you. And if you want to enable version updates, you need to add a Dependabot YAML. Also, semi-regular reminder that YAML sounds like the Dutch word jammer, which means too bad or unfortunate. And also the German word jammern, which is complaining, right? So that should tell you how I feel about YAML. Anyway, it's een beetje YAML. A little unfortunate. So in the YAML file, you need to say what your package manager is and the location of your manifest file, and you schedule an interval for it to run. And you can set some configuration, like the maximum number of PRs, where the default is 5. A rebase strategy, so whether it should or shouldn't automatically rebase the PRs, etc. It's GitHub native, and you can run it on GitLab too. The other option is Renovate, which on GitHub is available via an app. I used GitHub so that I could try all of these out for you. Renovate also has security updates and version updates, but it will also provide you with a project dashboard that shows you all of the outdated stuff for your project. It's available via a GitHub app, so still on GitHub fairly straightforward to enable. It offers you the option, if you've never used any one of these, Renovate is the only one that offers you the option out of the box to select only one repository. So if you want to give that a try, this is a safe way to do it. It will then create an onboarding PR for your project that contains some basic configuration. And once you merge that, it will start doing its thing. So the configuration options are you can enable it for all of your repositories or specific repositories. The config file is created for you. You can schedule when to run it. You can set a maximum number of PRs again, but also a maximum number of concurrent branches if you want to make sure that you're not overwhelmed with open PRs for security and other reasons. It has the option to auto-merge stuff based on rules. So if there are things that you think can be auto-merged without anyone looking at it, you can set it up to automatically merge specific updates. And overall, it has more options than Dependabot, and the options it has are more fine-grained than Dependabot. The Renovate PRs provide some information also on how confident they are that you can merge a particular update. So we'll tell you, these screenshots are a little old, sorry. None of the bots like it when you enable, disable, enable, disable, enable, disable them on your project, so it's hard to update these slides. But it will tell you how old the project is, the adoption rate among Renovate users, the number of passing tests among Renovate users, and based on that they provide you with a confidence level of how confident they are that you can merge this update, where neutral means that either they don't have enough information or they can't tell based on the information that they have. And they provide you with a dashboard for your project of everything that's outdated. For this project, pretty much everything, because that's the only example I use it for. And you can check the jobs that have run. It supports several platforms. This was as of a few weeks ago. The last option is Sneak Open Source, which is available via Sneak. Sneak offers also security updates and version updates. A feature that Sneak has that the other two don't is testing for vulnerabilities on incoming PRs, which is very nice. So it makes sure that you're not adding vulnerable dependencies in between your regularly scheduled scans. And also it has dashboards that are slightly prettier, as you'll see, than the Renovate ones. You can enable it via their website. You need to authorize them. You can select either private and public repos or public only, and you can set the different options that you can add, like checking new incoming PRs. And then they will provide, once you've enabled it, they will start doing PRs and provide you with information on why they want to update a particular dependency. Sneak out of the box will also bundle PRs that are related to the same dependency. You can also configure Renovate to do something similar. If you don't want to get overwhelmed with PRs, you can bundle them if they're for the same dependency. And of course, they have the check on incoming PRs. Dashboard, again, old projects that I don't update. The configuration options are slightly less. Then go away. are slightly less than renovate, but you can enable the frequency, daily, weekly, and never for some reason. So that's one way if you want to run it on only one project, but then you have to go disable all of the other ones. Something that's nice is they allow you to enable or disable either new or known vulnerabilities. So you can separately, if you know that your project is really outdated, you can first enable it for known vulnerabilities and get rid of your backlog, or only enable it for new vulnerabilities so that you know you're at least not making it worse. So if you want to do those separately. And it also works on a bunch of platforms. So the pros and cons are they're fairly easy to install. We used GitLab at my previous job, and we used Renovate. Someone had written down exactly how to enable it for GitLab. And it's less work, definitely less work than doing stuff manually. And it will create automatic PRs, meaning that you don't have to actively monitor if there are new versions, because you can tell by the newly created PRs. But those newly created PRs can create a bunch of noise that you have to deal with, because you have to manage those PRs and see if they're safe to merge and safe to deploy. And even if the build is green, it doesn't necessarily mean that stuff's not going to break in production. We've also had an example where a failsafe plugin was updated and the build was green, but in fact the integration tests were no longer running because of configuration options in failsafe probably. So even though we merged that, we had to revert that and fix that first. And none of these bots will make changes to your code if your code needs to be changed because of API changes or whatever, or if you have failing tests that you need to look into. So this is where migration tools can come in handy. IntelliJ IDEA has migration refactoring that unfortunately I was not aware of when I was updating JUnit 4 to 5. So I did that manually. So if you still need to update, let's take a closer look at that menu. If you're old and have bad eyesight like me. So we have pre-built migrations for you, Java EE to Jakarta EE, which might come in handy. JUnit 4 to 5 if you haven't already, but you've all have, right? Or Java FX, and you can create your own migration. So you can create your own map, and you can say, okay, I want to this old name to this new name, migrate these packages. If you want to know more about that, we have videos on the IntelliJ IDEA channel as well, because some of it can be handled by IntelliJ, but some of it you'll have to do yourself. Another tool that you can use is ErrorProne. Even though it's not technically a migration tool, I know that people have used it as such. So ErrorProne is a static analysis tool to catch common programming mistakes. You can use it with Maven and Gradle. There are plugins for your favorite IDEs. And what it does is it can find common bug patterns, and depending on how you configure it, either alert on those or fix them for you. It includes a tool called Refaster that will work with before and after templates. So you can say, okay, from this type of code, I want to go to this type of code. So it can actually make the changes in your code for you. And even though it's intended for bug patterns, for example, you're creating a new error, but you're not actually throwing it. I know that people have also used it for migration. So Sander Mak, who works at Picnic in the Netherlands, he's done talks on ErrorProne, and currently Rick Ossendrijver, who is also at Picnic, is doing talks about ErrorProne if you want to check those out. And I know that Sander has said that they've used ErrorProne to migrate from Java 8 to 11 in the past before. And they've also created their own fork that you can use if you want to give that a try. Another tool that you can use for code migration is OpenRewrite. OpenRewrite is a source code refactoring tool, and it can help you upgrade frameworks or do framework or API migrations. But it can also do vulnerability patches and static code analysis fixes. So if your sonar is lighting up with lots of stuff, OpenRewrite can help with that. And they started with early focus on Java, yay, and now are expanding to Kotlin, some Groovy support, Python, and working on JavaScript. So they have a lot of existing recipes that you can use. So we can see here as well, migrating to JUnit 5, migrating Quarkus, as well as check style violations and static analysis remediation. They have a whole recipe catalog. Some are managed by Open Rewrite and some are managed by specific projects. And you can author your own. So if you have, for example, an internal API that you're using and you need to migrate some code. And Tim, who works at Modern, the company behind Open Rewrite, is also here and talking about this later today if you want to go check that out. So overall, please make sure to evaluate which dependencies you use or re-evaluate occasionally. Sometimes they're no longer maintained or there are better solutions. Automate as much as possible and stay safe. Thank you. Any questions? Anybody want some stickers? I've already uploaded the slides, and you can find recordings of previous versions of this talk and related blog posts and videos and everything on this website. Thank you. Have a great conference.